Hello, this is Captain Chaudhari once again. Today I am going to speak about seasons. There are two main things to understand here in seasons. Number one, why the seasons are caused, and number two, why there is unequal duration of these seasons. So let us start from the basics. In our schools, we must have been taught that the sun's rays directly fall sometimes in the northern hemisphere, sometimes in the southern hemisphere. On the 21st March, the sun's rays are directly falling on equator. On 21st June, the rays fall directly on Tropic of Cancer, etc. etc. So let us understand the same thing with the help of a diagram. Here you have sun. This is the Earth's orbit around the sun, and I'll try to show the inclination. This way. Equator, so 23.5 degrees north, sun's rays are said to be falling directly on Tropic of Cancer. Now here, the sun's rays directly fall on Tropic of Capricorn, 23.5 degrees south. Over here, the sun's rays fall directly on equator. Here also, the sun's rays directly fall on equator. Now this happens on 21st March. Then Earth comes here. This is 21st June, 23rd September, and 22nd December. Now, this is vernal equinox, this is autumn equinox. Summer solstice, winter solstice. When the sun is focusing its energy in the northern hemisphere, we say it is northern summers, and vice versa. When the sun focuses its energy on the southern side, then we say it is southern summers. If we consider Earth to be at the center, concept of celestial sphere, sun going around ecliptic, the diagram could be drawn this way. Here is the celestial sphere. This one is equinoctial. First point of Aries. So this is ecliptic. Sun is here on 21st March. Number one is over here. Then sun is over here on 21st June. This is number 2. 2 is over here. Then the third is when the sun is on first point of Libra. Cannot see here, but that is this one. And the fourth is when the sun comes over here. The maximum southerly declination that happens on 22nd December. This is number 4, and that is over here. So here you can see in this diagram, basically there is a change of season because of the inclination of Earth's rotational axis by about 23.5 degrees on the ecliptic. So because of that, what happens is, if you look at this diagram, the sun's rays are kind of falling directly on 23.5 degrees north. When Earth comes here, the sun's rays fall directly on the equator. Sun's rays fall directly on 23.5 degrees south, equator once again. In the technical language, we say that if this is equinoctial, while the sun is below the equinoctial, the declination is south. While the sun is above equinoctial, the declination is north. So can we say in the journey from 21st March to 23rd September, sun maintains a northerly declination. From 23rd September back to 21st March, via winter solstice, the sun maintains a southerly declination. When the sun has northerly declination, there is more focus of energy in the northern hemisphere. Northern hemisphere experiences summers, and at that time winter is there in the southern hemisphere. While it is summers in northern hemisphere, there is a longer daylight also. The daylight is more than 12 hours, and vice versa. There can be only two reasons if a place experiences 12 hours day, 12 hours night. And that is number one, if the latitude is 0, and number two, when the declination is 0. So, when is the declination 0? 21st March and 23rd September. These are the only 2 days while there is 12 hours day, 12 hours night all over the world. There is yet another reason while a place experiences 12 hours day, 12 hours night. That is if the latitude is 0. For example, Singapore. Singapore experiences 12 hours day and 12 hours night throughout the year. So remember, if you want to have 12 hours day, 12 hours night, either the declination should be 0, that is on 21st March, 23rd September, or the latitude of the place should be 0. Why the duration of these seasons are not equal? When I say from here to here is one season, that is springs, and from 21st June to 23rd September it is summers, right? And from 23rd September to 22nd December it is autumn, and from 22nd December to 21st March it is winter. While the sun is traveling equal distance, why the duration of seasons is not same? The reason for that is equation of time. What is equation of time? Equation of time is the time interval or angle interval between the true sun and the mean sun. True sun is what you see in the sky, and mean sun is what you don't see in the sky and you have only imagined. There is no third sun. You don't have to worry about dynamic sun, real sun, apparent sun, etc. There are only two suns, and the interval between them is equation of time. Why there is equation of time? Why there is interval between the two? The reason for that is the Earth's orbit around the sun is eccentric. So there are two reasons basically which cause all the confusion in time. One is obliquity of ecliptic, and other one is eccentricity of the Earth's orbit. Sometimes the true sun is ahead, sometimes the mean sun is ahead. So when a season starts, a true sun may be ahead of mean sun or behind the mean sun. So we need to take into consideration the position of true sun, whether it is ahead of mean sun or behind the mean sun. So because of these two reasons, the length of seasons is unequal. So 21st March to 21st June is springs, that is 92 days and 20 hours. Then from 21st June to 23rd September it is summer, that is 93 days and 14 hours. Then you have autumn, that is 89 days and 19 hours, and winters of 89 days. So when you need to find out the length of seasons, you need to understand that although the sun is traveling by 90 degrees, there is some equation of time at the beginning, there is some equation of time at the end. We need to add this equation of time and we need to subtract the equation of time at the end to find out what is the length of season. Now to understand why length of seasons are different. In each season, sun travels 90 degrees on ecliptic, but still, why say for example winters is of just 89 days? So let us try and understand. This is celestial sphere, equinoctial, and here is the ecliptic. This is Aries, first point of Aries, 21st March, 22nd December. Now, one must understand that somewhere here you have perihelion, and at that time the sun travels very fast on ecliptic, and that is one of the reasons, that is the reason in fact why the winter, which is the journey of sun from here to here, is of the shortest duration. Let us do one example here. Suppose on 22nd December, when the SHA of the sun is 90 degrees, let us study the sun's movement from here to here. Over here the SHA of the sun, that is on 21st March, is 0 degrees. We need to calculate the journey, the time taken by the sun when true sun is here till the true sun is here. But if we look at the equation of time on 22nd December in any year, you will find that the equation of time is something like minus 24 minutes. That is on 22nd December. And on 21st March, it is say plus 1 degree 48 minutes. That means on 22nd December, the mean sun is here, because the equation of time is minus 0 degrees 24 minutes. And on the 21st March, the mean sun is over here. So actually, while the true sun travels from this point till this point, owing to its high speed, the mean sun has traveled only from here till here. If we total up this part and this part, it becomes 2 degrees 12 minutes. Now this 2 degrees 12 minutes is subtracted from 90 degrees, so that becomes 87 degrees and 48 minutes. Now by the equation that 360 degrees takes 365.25 days, 87.8 degrees will take how much time? Let us do this calculation. So we have 365.25 into 87.8 equal to divided by 360 equal to, it's about 89 days. So basically, although we are wanting to find out how much time the true sun takes from this point of maximum declination south till this point of equinox, we calculate the time, or our time is calculated not by the true sun, it is calculated by the mean sun. Mean sun is traveling about 2.2 degrees less than 90 degrees. So to move about 87.8 degrees, mean sun will take 89 days. That's why the duration of winters is 89 days.